Hi, this is Mr. Hikel. I'm back and I'm bringing you a podcast today over molecular and empirical formulas. Now there's 4 very simple steps you do whenever you do empirical formulas, and I'm going to read them to you verbatim. You also have them on the note sheet that I left you, but in case you don't have them, here you go. The first step is you're going to convert your percentage to mass. Once you do that, you're going to take your mass and you're going to convert it to moles by dividing by the grams from the periodic table. Once you do that, you're going to divide all the numbers by the smallest number, and I'm going to walk you through all these steps and explain them as I go. And then I'm going to multiply all of them by a number to make all of the numbers a whole number. So if you get like 2.5, you multiply 2.5 by 2 to get the 2.5 to a 5. So here we go. We're going to do number 1 on determining empirical formulas page. It's going to look something very similar to this. We have 75% of our compound is, so 75% is carbon, and 25% is hydrogen. Okay, so we're going to take our percentages and we're going to make them into masses. We're going to assume everything's out of 100 grams just to make our percentages easy. So we have 75 grams of carbon, and we have 25 grams of hydrogen. So now we're going to convert those grams into moles. Okay, so we know that 1 mole of carbon weighs 12.01 grams. Okay, it's the number that comes out the periodic table. We also know that 1 mole of hydrogen weighs 1.00 grams from the periodic table. So we're going to cancel out our grams. We are left with moles. So now we're just going to simply divide. Well, 75 divided by 12 is going to give us our number that we need for the conversion factor. Sorry, I got to find my notes real quick. So 75 divided by 12 is going to give us 6.25. And 25 divided by 1, well, that's an easy one. That's just simply 25. Okay? Well, this is not a whole number. Okay? It doesn't need to be, because we're going to divide both numbers by the smallest number. And then if it's not whole, then we're going to multiply it. So the smallest number here is 6.25. So we're going to do 6.25. 6.25. That's going to give us 1 right there. Well, 25 divided by 6.25 is going to give us 4. So our empirical formula for this specific situation is going to be C is going to be 1 and H is going to be 4. So it's simply going to be CH4. That would be our answer. That is our empirical formula. We have methane there. Okay? So now let's go down to the next page and let's talk about molecular formulas and how we use empirical formulas to work with our molecular formulas. Okay? So the steps are going to be very similar. Okay? So our first step on molecular formulas is we're going to find the empirical mass. So if we look at number 1, it says the empirical formula of NO2, and it says its molecular mass, so I'm just going to abbreviate that with an MM, is 92 grams per mole. Okay? So we got to find out how much this thing weighs. Well, we would do 14 plus 16 times 2. So 14 plus 32 is going to give us 46 grams per mole. Okay? These two numbers are different. So we know our molecular formula, which is what we're looking for, weighs 92 grams. Well, our reduced form, or our empirical formula form, weighs 46 grams. So we're going to do 92 divided by 46. That's going to give us an N value of 2. So we're going to multiply our N times 2 and our oxygen times 2. So our true or molecular formula is going to be N2O4. Because when you're doing empirical formulas, it's the lowest reduced version of a formula. So like a carbohydrate, you have sugar, which is C6H12O6, is glucose. So you can reduce everything by 6 and get CH2O. Well, the CH2O is the empirical formula from the molecular formula. So we're done with that one. So now let's move down to number 3 on this same page, where you have to do a percent composition, you got to find the empirical formula, and you have to do the molecular formula. Okay? So we're given carbon is 40% carbon, so we're going to assume it's 40 grams of carbon. It says 7.6% hydrogen, so we're going to assume it's 6.7 grams of hydrogen. And then it also says that it's 53.5% oxygen. So we're going to assume again that it's 53.5 grams. Now we're going to divide all of these by how much they normally weigh, because we're going to set up our little dimensional analysis chart. Well, we know that 1 mole of carbon weighs 12 grams. 1 mole of hydrogen weighs 1 gram. And 1 mole of oxygen weighs 16 grams. So we're going to cancel out our grams on all these. We're going to do the division. I've already done it for you. Kind of like those baking shows where they put something in the oven and it automatically comes out done. Well, I've already got it all done for you. I've got all the legwork done. So this gives you 3.3 moles. This gives you 6.7 moles. And this also gives you 3.3 moles. So we're going to do the same stuff we did when we were doing empirical formulas. We're going to divide all 3 of these by the smallest number. Well, that would be 3.3. So we're going to divide this by 3.3, this by 3.3, and this by 3.3. When we do that, that's going to give us our empirical formula. So we have 1 C, we have 2 H's, and then we have 1 O. So our empirical formula is CH2O, or a carbohydrate. It's just a water with a carbon attached to it. So we know the weight of this, we would do C plus H2 plus O. So we got to figure out how much the empirical mass is. So we would do 12 plus 2 gives us 14, plus 16 gives us 30 grams per mole. Okay? Our problem goes on to state that its molecular mass is 60 grams. So our MM is 60 grams. So we would take 60, let me erase some of this work here. We would take 60 and divide it by 30 to give us 2. So our M value is 2. So what that means is we're going to multiply everything here, all of our subscripts, by 2. Remember, if there's not a subscript listed, assume that it's 1. So we would do C2H times 2 is 4. That gives us our molecular formula of C2H4O2. So it's not very difficult to do empirical and molecular formulas. It's not even very difficult to do percentage composition. You just have to know what steps you do where. Again, I gave you a copious notes section on how to do it. It gives you the 4 steps: percent to mass, mass to moles, divide by the small, multiply to a whole. Make it a little rap song in your head and you'll remember very easy. It's very, very simple.